Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving maximum candies allocated to k children. So the problem basically states that we are given a zero-indexed integer array called candies. And each element in the array, it denotes a pile of candies of size candies of I. And our goal is that we need to allocate piles of candies to k children so that each child can get the same number of candies. And we need to remember that each child can only receive candy from one pile. He or she cannot receive candies from two different piles. So we need to take that into consideration when we solve this problem. And we want to return the maximum number of candies each child can get. So if you look at this example, in example 1, each child can receive 5 because one can grab from pile 1, one can grab from the second pile, and one can grab 5 from the third pile, and each child can have 5 candies. But we cannot do 6 because pile 1 doesn't have 6. And if we look at the second example, we would just return 0 because we cannot even split one candy to each child. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is we can use binary search. So the left side of the binary search will always be 1, and the right side will be the maximum number in the input array. So for this example, it would be 8. And what we will do is find the middle at each binary search iteration, and then we want to see if that number can satisfy k. So if it happens to be less than k, meaning it can only serve less than k kids, then we need to shift the right pointer because it means the number of candies that we are serving is a bit too big to fit into k number of kids. Now, if the value in kids that we get, if the kids that we can serve with the mid number happens to be greater than or equal to k, then we will set a current result as that number in mid, and then we will shift the left pointer because we want to see if we can try handing out more candy and can it still serve k kids. So let's go over this example real quick. So first, the left pointer is 1, the right pointer is 8. So then the middle value will be 4. So we try serving 4 candies and realize that we can serve 4 kids. 1 kid from this pile, 2 kids from this pile, and 1 kid from this pile. So currently, we will set the result to 4, and then we will shift the left pointer and see if we can try more candies. So after shifting the left pointer to 5, because we did mid plus 1, which is 4 plus 1, 5, and the middle between 5 and 8 would be 6. And if we try 6 candy, it can only serve 2 kids. We cannot serve any kid from this pile, 1 kid from this pile, 1 kid from this pile. So since it was too much, now we need to shift the right pointer. So we will set the right pointer to mid minus 1, which would be 5. And if we try 5, we realize that we can serve 1 kid in this pile, 1 kid in this pile, and 1 kid in this pile, and that's 3 kids, which is enough. So then we can set the new result to 5 because that's the maximum number of candies that we can serve so far. And after that, since it works, we will add the left pointer, and the left pointer is greater than the right pointer, so we can end the binary search, and our result would be 5. So the time complexity would be O of n log m, where n is the number of elements in the array, and m is the maximum number in the array, because that is what we're doing binary search on, and n because we will iterate through the array every time we want to find the number of kids that we can serve at each binary search iteration. And the space complexity would be O of 1 because we are not using any extra space. So now let's get to the coding part. So first we will set the left pointer to 1 and the right pointer to the maximum value in candies, and the starting result would be 0. Now while left is less than right, we find the middle value. So middle value would be left plus right, floor division by 2. And then we will set kids to 0 at the beginning, and for c in candies, we will do kids plus int divided by c, divide c by mid. And if the ending value of kids is less than k, we shift the right pointer, so it would be right equals mid minus 1. If not, then we shift the left pointer and set the result to mid. And after finishing the binary search, we can return result. Let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave down in the comment section, and I hope to see you all again soon.